So for this problem, to find the sum of this given series, since this given is a geometric series, then this is the formula to find the sum of a geometric series. Then from this given, this is the first term, the second term, the third term, and we have the last term. Then observe from this formula, so we have a sub 1, and a sub 1 is equal to positive 5. Then R, so R is the common ratio, so we can find R using a sub 2 over a sub 1. Since a sub 2 is negative 15 over a sub 1, that's 5. So therefore, the common ratio is negative 3. Then we have n. N is for the number of terms. Since from this given, the number of terms is unknown, because we have the missing numbers. So therefore, we need to solve first for n, or for the number of terms. So for this geometric series, so using the geometric sequence formula, that a sub n equals a sub 1 times r to the power n minus 1. Then substitute now all the values to solve for n. So for a sub n, this one is 32,805, then equals a sub 1, so the first term is 5, times r. R is negative 3, then to the power n minus 1. Then to simplify, so we need to divide both sides by this number. So divide by 5. So for this 32,805, divide by 5. So we have 32,805 divide by 5. So that's 6,561. So this is 6,561, then equals negative 3 to the power n minus 1. Then this time, since n is in the exponent, so we're going to use the logarithm to solve for this problem. So we need to ln both sides. So ln 6561, then equals. So we can bring down this n minus 1, then times ln. So we need to ignore the negative because there is no negative logarithm. So just ignore the negative. Then to solve for n, so divide both sides by ln3. Divide by ln3, so cancel. So for this ln 6561, divide by ln3. So we have ln 6561, then divide by ln 3. So that's equal to 8. So we have 8, then equals n minus 1. Then this becomes n plus 1. So transpose. So we have 8 plus 1 equals n. So therefore, n is equal to 9. So this series has 9 terms. Then this time, since we have now the number of terms, so we can solve now for the sum of the numbers. So from this formula, so we have now the sum of the numbers equals a sub 1. So a sub 1 is 5. Then times 1 minus r. R is negative 3. Then to the power n. N is 9. Then over 1. Then minus r. R is negative 3. Then to simplify, so we have the sum of the numbers equals 5. then times 1 minus, so this negative 3 to the power 9. So we need to put inside the parentheses for the negative numbers, then to the power 9. So that's negative 19,683. So negative 19,683 then over. So for this double negative, so this becomes positive. So 1 plus 3, this one is 4. Then this becomes the sum of the numbers equals 5. Then times. So again, this double negative, so becomes positive. So this becomes 19,684 because we have this plus 1 then over 4. So to find out the sum of the numbers equals, so we have 5 then times this 19,684 then divide by 4. So this is 24,605. So the sum of the numbers is 24,605.